We move our eyes from one point to another in order to fix...
Vision is far and away our dominant sense. And for George Pavlidis, it's a fascinating area of study.
I've read the Kleitman book he recommended, but I haven't read any of these.
He lectures in psychology at Manchester University. Recently, he's shown an intriguing link between the way we see and how well we read.
Well, not yet. It took me about 3 months to read them.
Why?
Well, I find reading a bit difficult. I'm a bit slow at reading.
If you like, read yourself.
His discoveries started with one of his students. She was bright, yet she could barely read. It's a problem that's been called dyslexia, though many feel the word is simply an excuse for poor reading.
Please. Could you look at these 3 objects, please?
But George Pavlidis wasn't so sure. He noticed that she seemed unable to move her eyes in any ordered sequence. They seemed to jump at random.
Please. 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 Okay.
He decided to pursue his discovery further. He designed a pair of spectacles to monitor people's eye movements precisely while they were reading. As a normal reader scans the words, the spectacles record the direction of her gaze. 2 minute sources of infrared light illuminate one eye. The reflections can be used to calculate its position. The result appears as a moving dot on a screen. It shows exactly how she scans the words, how she reads. Her eyes move in a series of rapid jumps. The moving dot shows that the jumps add up to a steady forward scan. Now, George did the same for a boy known to be a very slow reader. He found that the pattern of eye movements was closely similar. As he read, he focused on much smaller groups of words. Regressions were more frequent. Progress was much slower, but overall, the dot revealed the same steady forward scan.
Is it okay now?
It's comfortable, yes.
Thank you.
But when George tested his student, the one he thought to be dyslexic, he found a very different pattern. The spectacles recorded the wildly erratic eye movements he'd already observed. Little wonder she found it difficult to read. For her, the page became a meaningless jumble of odd phrases and words. Her eyes appeared to jump at random backwards and forwards along the line, even from one line to another. As her eyes bounced back and forth, she read some words not from left to right, but backwards. Through her erratic eyes, the word was can look like saw.
You can see the clear-cut difference in the eye movement patterns. This is
A series of tests with different people convinced him that dyslexics were quite distinct from other slow readers.
A very slow reader moves across the line with very small steps. Unlike you, where you move forward and backward in an almost random way.
He's now sure that in dyslexics, the brain is simply unable to move the eyes in sequence.
But anywhere around the line. And this is the huge difference between dyslexics and any other kind of readers, including backward readers.
So he's devised a test. It's designed to detect this strange pattern of seeing in young children.
Okay, Lisa, we'll take off the glasses now, okay?
He believes that if the problem can be detected early, dyslexic children could be taught to control their eye movements, while the young brain is still sufficiently plastic. He's not yet sure how, but early detection would be an important first step. Instead of words, the children have to follow a series of flashing lights, so age, language, intelligence are not important. And for young dyslexics, the chance of help from research into the way we see. If you'd like more information about today's program, write to Living Tomorrow, P.O. Box 48, London, SE1, England.